Hey everybody, I'm Michael Dowling. Today I'm going to tell you about a PHP HTTP client and web service client framework that I made called Guzzle. So I would guess that most of you are probably using some kind of HTTP client. And you might even be interacting with one or more web services in your applications. And the reason I say this is because more and more applications are requiring web services just in order to even function. So like you might be using a Solr search server to populate the results of a shopping cart. Or maybe you're downloading RSS feeds or authorizing credit card transactions. Well, I know I've faced these kinds of problems, so that's exactly why I wrote Guzzle. I wanted to make the process of creating web service clients easier for vendors, but also the process of consuming a web service easier on developers as well. I'm Michael Dowling. I work at Amazon Web Services on the AWS SDK for PHP. And basically, that's the SDK that allows customers, PHP developers, to connect to AWS and use services like Amazon S3 or EC2. I'm also the author of Guzzle. And the reason I'm the author of Guzzle is because I've had to write a ton of HTTP clients. At my previous position at an e-commerce, we used a lot of third-party APIs. And the APIs that we used, the vendors didn't often have a PHP client. Or if they had one, it wasn't something that we could use in production. Maybe there were performance issues, or it emitted warnings or something like that. So we ended up having to write a lot of HTTP clients over there. And so let's talk about HTTP clients and the different ways that you can send requests in PHP. And you're probably using one of the methods that I'll list here. So first up is the HTTP stream wrapper. And we all use this and we know it, and it's great for really simple cases. So to send a GET request and to get the body of that GET request is really easy. And it's built right into PHP. So you don't need to worry about if your users have it installed or anything like that, and you know it's always going to be there. But it's not really without its warts, in that you need to work with stream context if you're doing any kind of sufficiently complex operation. So basically anything other than a GET, you'll have to create a stream context and pass that in. Also, it doesn't support a lot of performance optimizations that you can actually get with HTTP. For example, if you were to send a lot of requests to the same server over and over, you can actually keep that connection open. It's called a persistent connection. And if you don't do that, then what you have to do is open up a new TCP connection, do a TCP handshake, and if you're using SSL on top of that, you have to do the SSL handshake as well. So it's a big performance penalty if you don't use that, and the stream wrapper doesn't actually support persistent connections. There's also no support for parallel requests. So if you need to send 10 requests to a server or to multiple servers, you can actually do this in parallel by opening sockets with each one and then polling them and then doing something, an action on one of the sockets as something can be done or data is available on that socket. Also, the biggest ding, I think, is that data has to be loaded into memory. So if you're sending a post or a put request with gigabytes of data, you have to load that into a string and pass that into your stream context. So that probably won't be possible to do. You'll have to look for another client. And then this is an example of how simple it is to get the contents of a web page with file get contents. It's really easy, just file get contents, pass in the URL, and you can get the response headers using the HTTP response header magic variable that they inject. And this is the stream wrapper using a context. And it's not terrible, but it kind of makes the API a little bit too clunky for me. And you have to pass in false to say you're not using the include path, which isn't really relevant here, and then pass in your context. Next up is curl, and curl is awesome. It's what I built Guzzle on top of. It's really fast. It supports pretty much all of HTTP. So anything you would want to do with HTTP, curl is going to be able to do it. And it can do a lot of other protocols like FTP, SCP, or even Gopher. It supports streaming requests and responses. So you can stream data from a resource or a callback function or anything like that. And a lot of people use curl. It's really common to be installed. But it's got a pretty cumbersome API if you're going to use it directly. And this turns a lot of people off because it's parameter driven. So you create an easy handle and you inject a bunch of curl options on it. And what can happen is, say you're reusing that easy handle over and over because you want to use persistent connections. Some things, what it does to your request can only be unset as a side effect of adding another option. So there's a lot of like tribal knowledge that you have to know in order to really do a good working implementation with curl. And here's an example of how complicated the API can be. And this is kind of complicated. What we're doing here is we're sending a put request to example.com. and streaming the contents of Amazon.com's web page in the body of the put request. So this is accomplished with a curl opt read function setting, and curl is going to invoke this function anytime it can send data over the wire. And then finally, that function might return an empty string, which will stop the transmission. Peckle HTTP is really cool too, and it's almost as powerful as curl. But I think the biggest problem with it is that it's not often installed by default on different user systems, and it requires a custom extension. So library authors are usually too, they don't want to make this a requirement and limit the number of people that can use whatever their product they're offering. Another option is sockets, and I guess the only pro I can think of for using sockets directly, like fsock open, is that you get the most control over your transaction, because the reason for that is because you actually have to control literally everything about it. You have to open the connection, and you have to do all the HTTP application level as well. So RFC 2616 is super complicated. That's the HTTP spec. And there's a lot of state transitions and context that you have to keep. So if you are looking for an HTTP client and you want to write one or you want to use one, I would say don't try to reinvent the wheel and do sockets. I would probably use curl, because it's been around for 16 years and it's used by a lot of people. And then you get to PHP land clients, and there's a lot of them on packages, and there's some popular ones. I've listed them here. And all these clients are good in their own way, so you should go and check them out and see what works best for your use case. But we'll talk about Guzzle today. Guzzle supports all the good stuff we talked about, so persistent connections and streaming and parallel requests. But also, it's extensible from the ground up with a plugin architecture that's powered by the Symfony 2 event dispatcher. And it allows you to modify the behavior of a client, the behavior of a request, all the way from creating a service builder to creating a client to creating a request from that client. And it's also backed by a web service framework that's on top of the HTTP layer. And that allows you to more quickly consume a web service using a description of that service. And it does require curl, but requiring curl in your project isn't that big of an issue. It's actually a non-issue. And the reason for that is most of the people using your library would already have curl installed. So popular libraries already require curl, like AWS SDK for PHP. Magento requires curl. Facebook's PHP SDK. Google's various SDKs require curl. PayPal. So it's really common that that's the mechanism that they're going to use this in requests. Also, most shared hosts already support curl. Like GoDaddy, DreamHost, ServerGrove. Most of them that I did my search with, they all either said they supported curl, or I found somewhere in the forums where they mentioned that yes, they support curl. So it's really common. That should be a non-issue. And just for fun, Daniel Stenberg, the guy who wrote curl, he recently estimated that curl is being used in some form or another by 550 million people. And that's 1 in 4 of the 2.3 billion people that use the internet. Installing Guzzle is really easy. You just put this composer.json in your project and composer install. And then what this is going to do is it's going to bring in all the dependencies of Guzzle. It's going to bring in the common layer. It's going to bring in the plugins. It's going to bring in the service description layer. There's some inflection and some iterators that you can bring in. And it's great because it brings it all in, and you don't need to worry about pulling it all in yourself. But if that's not lightweight enough for you, Guzzle's also been broken apart into components. So you can get just the HTTP package. This would be the most minimal installation, and that would just pull in Guzzle common and the Guzzle HTTP package. Or say you need just the mock plugin. You can also pull that in as well. This was actually something that I ended up implementing that helped Drupal to adopt Guzzle as part of Drupal 8 core. And I mentioned that Drupal is using Guzzle. So Guzzle is used in the wild by a lot of people, but I'll call these people out here. Amazon Web Services use Guzzle to power the AWS SDK for PHP. I joined Amazon a little over a year ago, and we wrote the SDK from scratch to leverage Guzzle and some of the more modern coding practices in PHP today. Drupal 8 also made Guzzle part of Drupal 8 core, and Gout is a web scraper that uses a bunch of Symfony components, and that is powered by Guzzle as well. Tumblr rewrote their SDK to use Guzzle. But I want to talk a little bit more about the Guzzle and Drupal integration. So right after adopting Symfony 2, the Drupal developers were looking for a good way to replace Drupal HTTP requests. because it was apparently hard to test, it was a big function, and it was used everywhere. But in their search for a good client, they made a head-to-head comparison of a bunch of different libraries. And the one that had a lot of checkboxes next to it, I guess, was Guzzle, so they ended up choosing that. And I added a few features that they were looking for, like there's a poor man's cron is a thing that they have that does cron jobs, but they want to send a request and not wait for the response. So just once the server's gotten all your data that you're sending, you sever the connection. So I added an async plugin, a couple other things like that. And this adoption's great. I think it's going to be great for Drupal. I think it's going to be great for Guzzle and really introduce the project to a lot of people. So we'll talk about HTTP clients and what Guzzle can do there. So in Guzzle /client, Guzzle HTTP client, this is the glue of the framework. This is the brains, the thing that creates requests and associates a response with that request. It also has plugins, so you can attach a plugin to a client, and then when a client creates a request, it'll also attach that same plugin to the request. So it's like an inheritance of requests of plugins that you can do. And they also have base URLs. So a base URL is a way that you can interact with an API, and you can send requests with a client that has this base URL. Say here is twitter.com's API. You can send a GET request using a relative URL, and this gets merged in to the base URL of the client following ROC 3986. And URI templates are also used throughout Guzzle. So that base URL could contain a URI template expression. So if you look, there's a version parameter that's referenced with braces around it. So that's a variable expansion. And when the URI template expander sees one of those, it's going to look at the configuration options passed in to the client, and it'll pull that out and inject it and substitute it. Also, Peckle URI template is a cool extension in Peckle that can speed up the process of expanding these templates. Here's a simple GET request. You just call the GET method on a client. So any HTTP method that there's like put, post, get, delete, head, patch, and any custom method you want. When a client gets one of these methods, it's going to create a request object and return that to you. And then in order to invoke that request and send it, you call the send method, and that's going to yield back a response object. And that's what it looks like over the wire when you send it. It's going to have a host header and a user agent with some Guzzle stuff. And here's how you would do that with the QBasic port of Guzzle that was released. And here's responses. So response is an object that's returned, and that object contains an entity body, and an entity body can be read from like a stream. So that data, by default in an entity body, is stored in a temporary PHP stream, which the way that works is once it gets over 2 megabytes of data, it switches from being an in-memory storage to a on-disk storage. So that will protect you memory-wise by default out of the box. And there's also some convenience methods like JSON and XML to get, if it's a JSON response, you can get an associative array. And if it's an XML response, you can get a simple XML element. There's other stuff that you can pull out of a response. You can pull headers out by name by calling the getHeader method. But also there's helper methods on a response object. So you could get the content length header as a string or get content type. Post requests are pretty easy too. You just pass in a hash of the parameters, and these are going to get serialized in the post body, and it's going to look like that. It's just pretty simple. And same thing, this is QB Guzzle again, how you would send a post request. Streaming data is built in as well. So here, we're sending a post request to example.com, and we're going to stream the contents of this Amazon.com's body, the web page of Amazon.com, to example.com. And you see we're passing in fopen. So this is a stream resource from PHP. And Guzzle is going to convert this to an entity body object for you. And an entity body object just kind of encapsulates the data that gets sent over the wire. And if you need to manage the lifecycle of a resource yourself, so here we're creating this resource and not managing that entity body object. So when the ref count of that resource gets to 0, it's going to get unset, so it'll get garbage collected. If you want that to persist after you've sent the request, you can create an entity body and then inject it in. And then also, we're streaming to path to file. So once we're done sending data from this stream, we're going to stream the data to this file as well. So there's ways that you can stream out and stream in to different locations. And because we didn't specify a content length here, and that content length it can't be determined by PHP. It's going to just automatically send it with chunk transfer encoding. Error handling in Guzzle is, there's two different types of errors. There's application and protocol errors. And this can happen when you get a 400 or a 500 level response. So that's going to send a bad response exception. And more specifically, you can get a client error response or a server error response exception. And then also there's transport or networking errors that you can get with curl. So if it times out or you can't resolve the DNS. HTTP errors are, this is how you would actually try catch if you were trying to catch a bad response. So you can get information like the URL and the headers that were sent. And QBasic doesn't have exceptions, so you have to use an on-error go-to. Parallel requests. So to send requests in parallel, you can send a request using the send method of a request object, or you can use the send method of a client and pass in an array of requests, and all these requests are going to get sent in parallel. So when you send requests in parallel, an exception could happen at any one of those requests. And the way that you can deal with that is catching a multi-transfer exception. And this is going to contain a list of the failed requests and the successful requests. So it makes it really easy to deal with that. And I didn't have an example of that, so here's just some games I made in QBasic. Is this Sumo? So the Symfony event dispatcher is basically the glue of Guzzle. It's the thing that you add behavior. It's where the customization layer comes in. So everything from the ground up is extensible through events. So for example, when a request gets sent, it emits a request.beforeSend event. And when it completes sending, when it's done with the transfer, you get a request.complete event or request.sent as well. So you have all these events that you can hook in and modify the context that's passed through these events. Anything that has an event dispatcher will implement this has event dispatcher interface. And there's two ways to listen to events. There's event subscribers and event listeners. So let's say that you have a web service you're using, and you need to use an auth token with that web service. And that auth token expires periodically. In order to use that service, you have to authorize, and then if it does expire, you have to refresh that auth token. So you could have your users have to manage this, and so when their auth token expired, they would catch that exception and deal with that themselves. But I think a better API is to make that transparent to the user, and automatically, if you get a failure that says, hey, you got a 401 response, you can key in on that in this event here, get a new auth header, inject it into the original request, retry that original request, and then inject that new response into it. So this is transparent to the user. They don't know that they authed out, that they timed out, and they don't need to. So I think this is a much better API. You can see that the event object that gets passed in, it's basically like, it looks and feels like an array, but it's really an array access object. So there's no exceptions or no warnings emitted if you reference keys that aren't there. So I mentioned event listeners and event subscribers, but I'll tell you what a subscriber is. A subscriber, it's a way that you can encapsulate the thing that your behavior modification does. So with listeners, you register and you give it an anonymous function or a callback or something, but you might have to do multiple things with that listener. Like say you're doing that auth thing we talked about. Request.beforeSend, you would inject the auth header, and then request.error, you would do error checking and handling. So having to inject these two listeners yourself twice, like exposing that as well, is kind of a bad design. So you can actually encapsulate that and hide that by creating an event subscriber. And these can work across the entire request lifecycle. And they're also easier to share. So say you're doing something that you're going to reuse or you want other people to use, definitely use an event subscriber. Guzzle plugins, there's a lot of them. And I'm not going to talk about all these, but I'll just point out a few of them. So the backoff plugin, say a request fails, you can set up a custom workflow that tries to determine, should I retry this request? And if I should, how long should I wait before retrying? Should it be instant, or should I use exponential backoff? So that's with the backoff plugin, you can do that. And that's used in the AWS SDK for PHP to power our exponential backoff. Also, cache. There's a full RFC 2616 cache component in the PHP client, in the client, that it works just like your browser. So if you go to a web page and you've already visited it, you can send a conditional get, and that could give you back like a 304 not modified. There's also a mock plugin. So it's great for testing. Say you you don't want to actually send a request over the wire in your unit tests, you can create a queue of response objects. And as requests get sent through that event listener that the plugin uses, it'll actually inject those mock responses. And then finally, the OAuth plugin is also very cool because it allows you to interact with OAuth services like Twitter without any really heavy lifting on your part. The anatomy of a plugin. So the only thing you really need to do is implement get subscribed events. And this is going to just return all the names of the events and map them to a function on that class. And your events, when they get triggered, it's going to send an event object to whatever function you said. So here's an example of the curl auth plugin. Attach this to a request or to a client, and before it sends, it's going to send a basic auth header with it. So here in the client.create request, it's going to inject the username, password, and a basic auth header into the request object that's been passed in as context to the event. So you can build up your own plugins like this if you need to modify a Guzzle client, but you don't want to necessarily subclass or override existing behavior. And the way in which you would attach this is you just use the add subscriber method of anything that implements the has dispatcher interface. So web service clients, let's talk about that. What is a web service client and what does it do? Well, here's what I think. I think most web service clients wrap curl in some form or another, and sometimes they get it right and sometimes they don't. So for example, if you're a curl wrapper, most of them that I've seen, they typically create a new curl handle for every request, which doesn't benefit from persistent HTTP connections. And whether or not they use error handling whenever they're actually interacting with the curl API, it's pretty rare because anything in the curl API can return a curl error and not work. So you need to test for that as well. Most of them create functions for every API operation. Error handling or extensibility, that's not often thought about in these. And the reason is because most of these are written in a bubble. So they're thinking about their specific use case and exactly what they think their customers are going to want to do. But people have they want to do different things, and everybody has their own use cases that they need to meet. So in order to do that, I think that events and plugins like that allow you to really modify things. And this is the reason that I wrote Guzzle. Because people shouldn't have to keep writing the same curl wrapper over and over. And they shouldn't have to worry about low-level plumbing that Guzzle takes care of for them. This allows them to stop focusing on that and really just focus on delivering something that's quality to their users. And all of this web service client layer, it all starts in the Guzzle service client object. Guzzle service client extends from a Guzzle HTTP client. So it has like the get, send, and put methods. But also it has a concept of sending and executing command objects. And it has a service description. And it can be created by a service builder. And we'll talk about all those. But a command is basically the encapsulation of an API, of an operation on an API. It defines inputs. So if you have to send like a username and a password in a command, then you can define that and then say what type it has to be or if it's required. It also does serialization of requests. So a command's going to know how to take an associative array and then map that to an HTTP request. And then it's going to know how to do it the other way around, to take an HTTP response and map that back into an associative array type object. There's two different commands you can create in Guzzle. There's concrete commands, which is basically an actual PHP class. And this is going to be a class that extends from the abstract command object in Guzzle. So a concrete command here's an example of where it would be. If you're making myclient.php, you would have a commands folder, and each concrete command you add would be under there, and it would extend from that class. These are more low level, I think, and they are more tightly coupled to an API. I think that they're harder to test and they're harder to write as well. So that's why operation commands are a nice feature in that these are powered by a service description, which you don't have to write PHP code. You just write that description that says what things are and where they go and how they get sent. And it's a lot higher level. It's an easier abstraction to work with. So to define an API with a service description, use a JSON document. And that document defines the inputs, defines the outputs. It can define errors that can be encountered when you send an API operation. And the cool thing I think about service descriptions is that they can be versionable and swappable. And by that I mean, let's say you're interacting with a web service and they have a breaking change in their API. You can easily just inject like the 1.1 service description into that client, and that client can start consuming that new version of the API. But say you still need to work with the 1.0 version, you can create another client and just inject the 1.0 service description. And then service descriptions also open the door for other really cool ideas that you could do API documentation generated from the service description. You could create some kind of, like the way that Swagger UI has they have a server that's powered by a service description, and then the client can also consume that same service description, and they generate documentation from that. So it makes sure that all your client, your server, and your docs are always in sync. And then it opens the doors for, you could generate code and create a Ruby client or a PHP client with actual concrete classes. So the top level of a service description looks like this. It has a base URL, which is what we talked about with a client, and it has operations. These are the actions you could take. Models are shareable snippets of JSON schema that you can inject throughout, and then you can also include other service descriptions. Operation looks like this. You can extend from a previous operation, so you could define like say you're working with a web service that only changes one small minor detail with every different operation. You could define that as an abstract operation and then extend from that and only make that minor tweak in each individual instance. They also have response classes, and what this is, it's going to be a string that references one of those models by name, and that tells the command how to parse that response object. And then most importantly, I think, is parameters. So parameters follow JSON schema, like I said. They have properties. If it's an object, it's going to have object properties. They can be arrays, strings. It gives you that validation and type. You can check to make sure that the right types are passed in. But also, you can inject default and required values into your service descriptions. And parameters have locations. So top-level parameters in a service description, it's going to have a location value, which is going to be something like URI. So that means inject this into the URI of the HTTP request. Or it might be a header or the body. So Guzzle is used by the AWS SDK for PHP. And the original authors were looking to replace the SDK with the library, and they thought Guzzle made a lot of sense for it because it matched a lot of the use cases they had. And then they thought it made even more sense to hire the guy that wrote it, so I ended up moving to Seattle. We rewrote the SDK, and now it supports 31 web service clients. And some of those clients have multiple versions. So that would be a monumental undertaking. If you were to write these clients by hand and create all the classes that you would need and think of the testing you would need to do, that would be monumental. So we tackled it, going about it a different way by having these meta service descriptions. And I think that really helped our team in order to actually, to achieve that goal. I think it was a big enabler for us. So here's an example from the PHP SDK of an Amazon S3 put object operation. So what this is doing, it's uploading a file to Amazon S3. It's not every parameter. I truncated it just to be more interesting and fit on the slide. But you can see there's parameters. And this bucket parameter here, it's actually referenced using a URI template in the URI of the operation. And you can see that it's got a location of URI, so that hooks it up, and the serializer knows where to put it. And then on the right there, you see input. This is what it's going to look like when you create a command. When you create this put object command and you pass variables in. It's going to match bucket against the service description, and then it's actually going to get serialized. If you look below, that shows how it gets serialized into the path. Same exact thing with key. There's a cool little star thing on the URI template, and that means that you can pass in an array of values for that key or a single value. And if you pass in an array, it's going to get imploded using that slash separated at the beginning. And then body as well. This is just showing you can set a location of body, and this can be an entity body object or a string or a PHP resource, and that gets serialized in the body of the request. So parsing a HTTP response, similar. If you notice on this slide, it has a response class of put object output. So when the response comes back, it's going to look for this put object output definition, and it's going to walk the rules and pull things out of the HTTP response object. So here, Same kind of thing, you have an eTag parameter. You want to pull this out of the eTag header and inject it into your model. It's a Guzzle response model object. The interesting thing about request ID is that you can represent things in a more approachable way than actually having to force people to interact with the serialization format. So xamz-request-id would be kind of clunky to have to work with directly. So we use a syntaz parameter to say, here's how it's represented over the wire. And then use the key request ID is the key that gets injected into the model. So with all this information, now we're going to build a Twitter client that uses a service description. And the Twitter API is pretty cool. They have a lot of nice documentation that has the types and different operations you can make. So using that data, I wrote this very small service description. It doesn't do everything. I just implemented the get mentions operation. So you can see that get mentions, it's got a response class of get mentions output. So that's the object that it's going to use whenever it parses an HTTP response. Also, we're using additional parameters here. So Twitter's API, most of the parameters are query string. So instead of me defining each and every one of them, all I had to do was define this additional parameters that says, anytime I get some arbitrary value in my command object, serialize it with these rules and validate it with these rules. So here I've said, anytime I get an additional parameter or any value, I'm going to serialize it in the query string. And it's kind of the same thing with get mentions output, the response model. That's going to take anything in the JSON, any top-level JSON key, and inject that into your response model. Here's how you would actually use a service description. You create a service description object by calling the factory method and giving the path to the file. Or you can give an array or an instantiated object. And then you just call set description on the client, and that client can then start using those actions that you defined. But in order to use the Twitter API, you actually have to use the OAuth plugin. So here we're just creating an OAuth plugin and adding it as a subscriber to the client. So now all requests that we send are going to use OAuth, and here we're creating the get mentions operation. We're going to send count, and count is going to be serialized in the query string of that request. And then that's going to return a Guzzle service resource model object, which it's also sort of like an associative array in that you get all the data back and you can reference things by key, but it also has helpful methods like get path, which you can traverse nested structures using slashes as a separator. And here's an example of we're just pulling out the status value from that response. So this would be status would be one of the keys in the JSON data that gets returned in the response. But I think that was a lot of wires that we exposed there to our users. Like if you wanted to tell someone this is how you use the Twitter API with Guzzle, like you're exposing a lot of details on how you implemented that. So we should use a way that we kind of hide that. We should use a method that can hide that, and our bootstrapping process is encapsulated. So we can do that with a client factory method. So all clients should implement a factory method. It's a static method that accepts an associative array and then turns that into a working client object. And what this does is it encapsulates that bootstrap process. It hides it from the user and makes just a cleaner API. It provides input validation as well. So you can make sure that you have your OAuth parameters, and you can make sure that if you don't have something, you can give a default value as well. And client factories are used by the service builder, which is an abstraction layer in Guzzle that allows you to use a single configuration file and create clients based on the data that you define in that configuration file. So you can reference a client by name, and it would know how to take the configuration values and inject it into a factory method. Here's an example of that Twitter client that we made, but condensed into a Guzzle service client object. So it's a lot cleaner. It doesn't expose the inner workings of it. And you can see that we're using the collection from config method. This is the helper method that you would use in order to actually validate those keys are passed in correctly. You can say, like, here's the config that I'm giving you, and an array of default values. We're not using any defaults here. And then an array of required values. So we're requiring all the OAuth stuff. And then you just create a client, set the config, add the OAuth subscriber, and set the description on the client object. And you return the client, and then now you have a working Twitter client. And you create it using the factory method. And just here's an example of the get mentions. This is going to use a magic method that can match against all your service description operations by name. So these methods aren't actually defined on the client. It's going to use the _call method in PHP to resolve that automatically. So you don't need to write a bunch of boilerplate functions for your clients. And so first, whenever you're doing this magic method, it's going to look in the commands folder to see if you made a concrete command. And if there's not one, then it's going to look in the service description for that key of that operation. There's a lot of other features in Guzzle that I'm not talking about today, but I'll just kind of cover them really quickly. Service builder configs, we talked a little bit about that. That's how you abstract away the configuration process of clients. Resource iterators are a way that you can iterate over a paginated response. So say you have a web service that, similar to, say, Solar's API, where you get back a single page of results, but then you can send subsequent requests to get that entire set of results. And that kind of encapsulates that logic and hides it from your users, because they really shouldn't have to know how that works. They should just know how to pull data out of your API. Also, there's a lot of batching abstractions in Guzzle that allow you to create basically a queue that you add requests to. And then the batch abstraction knows if there's anything fancy it can do, like combine requests into a single request, and maybe that's going to be more performant. The future of Guzzle, there's a lot of stuff that's in the pipeline. For example, I'm looking at creating more tooling. So maybe a command line interface that can convert a service description from, say, Swagger or a Waddle description and serialize that as a Guzzle service description. Also, looking at implementing a simplified type procedural API, similar to, say, Python's requests. So you would have like Guzzle : get, and that would use an internal client object from Guzzle created for you. Instead of having to interact with a bunch of objects and use statements, you could just use that simplified interface. And then if you have any other suggestions, let me know what you'd like to see. I'm always open for it, and we can add new features. So I think that Guzzle provides a lot of helpful abstractions for common tasks for HTTP clients. And it helps you to not have to worry about those low-level implementation details and just really worry about providing something solid for people. And it probably wouldn't make sense to put all this work in just one vendor's web service client. Like, you wouldn't put all that effort into making a cache plugin or making a log plugin, because you might not need it, or people might not need it. The value is not there. So being able to use Guzzle, a framework, it's going to provide that to you, and you don't have to write it. And you can give people access to these really powerful tools, and it's the right thing to do. So hopefully you've gotten a better understanding of Guzzle. And if you have any questions, And also, by the way, I have cards up here, AWS $100 gift cards, or not gift cards, credits. If you want one of those come up here, talk to me. But does anybody have any questions? Sure. Right. No, it's a completely separate deal, yeah. Right, web services, so like Amazon EC2, DynamoDB, S3. There can be. For example, I think Cloud Search has multiple endpoints in the way in which you use that client. Yeah, and some of them also have multiple versions. Like DynamoDB has 2 different versions that we support. And so because we're using service descriptions, it makes it a lot easier to maintain those clients. And so not only do we have to create those clients, right, but we also have to maintain them over time. So trying to maintain 31, and then there's an always growing list of new services that are coming out. So it really helps to make that a simpler process and easier for us. Any other questions? Sure. Right. So I looked a lot at Swagger, and Guzzle is actually based a lot on Swagger. But Swagger wasn't actually flexible enough for us to use it in all of our 31 clients. So I had to make some changes in order to actually facilitate that. So the process of taking a Swagger description and changing it to Guzzle, it's pretty simple, but I just want to make a tool that automates it. So for example, with Swagger, you can define a URI and a method, and that maps to an operation in your API description. It looks very similar, but you can't have multiple operations at a single endpoint, which is pretty common for different, say, a query string-based API that instead of using different HTTP methods, you might use post for everything, so like an RPC style. So Swagger wasn't flexible enough to describe that. Waddle doesn't have a lot of adoption. I mean, it's got a format, but not many people use it. And it looked really complicated, so I didn't use it. But yeah, so it's a pretty simple process to convert. So hopefully I can make some tools that help you to do that. Also, the Guzzle descriptions, I think, have a lot more PHP-specific helpful functionality that you can utilize. So you can register filters with an input parameter. And that filter would reference a function or like a static function on a class or a function in PHP. So you could register a filter like str to upper. So make sure that this is an uppercase string when you serialize it. Any other questions? Yeah, that would be really cool. I actually looked into that. So there's a Nelm.io API doc bundle, I think is what it's called. And you can take annotations from your different routes and different plugins that you use. So it knows how to take a form object, and it knows how to use the Sensio extra bundle or something like that. So it knows a bunch of different bundles and the annotations they use, and it can normalize that and output sort of a service description similar to this. Played around with it. I couldn't get, there's not actually very much introspection there, so I can't get everything that I need in order to create a service description for Guzzle. So I think that it would just need a little bit of modification in order to make that work, or maybe something else that's completely custom. But yeah, so you could also do that with say, Silex pretty easily. If you created a controller provider that maybe you give it your service description, and then that could automatically register routes for you. And then when you get an HTTP request, it could check against the request object you got in, and then knows how to parse that and knows how to serialize a response. So there's a lot of opportunity there too, and I think it would be a really cool thing to explore. Anybody else? Okay, well, thanks for coming.